Okay, so we're about 2 minutes past the hour, so we'll go ahead and get started. Thank you everyone for joining us today for this webinar on our new Q-Cloud product, which is basically allows people to run Q-Chem calculations on AWS, Amazon cloud computing resources in a straightforward, simple sort of way. So just to give you sort of an overview of what we'll be talking about. I'm obviously going to be talking about Q-Cloud, but I'm also going to be talking a little bit about the journey that we took as a company to sort of get to the product that we have now. Because if some of you remember, we actually did an initial launch of Q-Cloud back in 2022, and there are reasons that we are relaunching it now as kind of its own separate, unique product. And so I'll talk about sort of a couple of the design decisions that we made and things like that as we sort of considered how to improve this product. And then, so I'll, go through the infrastructure of our new Q-Cloud product and sort of talk through how it works and things like that. And then I'll talk about a couple of different setup considerations as you sort of, are thinking about how to set up if you are setting up your own Q-Cloud cluster. And then I'll cover a few use cases, and then we'll have a little bit of time at the end for a question and answer session. So if any of you have questions, and actually I think I need to turn on the webinar chat. So yes, okay, there we go. So if anyone has questions, you can go ahead and post them in the chat down at the bottom, and we'll be able to answer those at the end of the talk. So let's go ahead and get started. So first we'll talk a little bit about sort of why cloud computing has become such a point of interest for a lot of quantum chemists. So cloud computing, as most of you are probably aware, is basically the practice of using remote servers hosted on the internet at some remote location to store, manage, and process data rather than your own local servers. So down here, I actually have a picture of some of the servers in the Q-Chem office. But this basically allows you to store your data and perform your calculations using hardware that someone else maintains for you. There are a couple of different, drawbacks and benefits to this. We'll mostly be talking about the benefits right now since we're talking about cloud computing. But one reason that a lot of people are gravitating towards this, and quantum chemists in particular, is flexibility. So in terms of running high throughput calculations, if you're running a large volume of calculations sporadically, it's very nice to have sort of this scalable set of resources. So you can scale the number of nodes that you have up or down, depending on how many calculations you and your team are doing. And this scalability means that you get a lot of savings in terms of the infrastructure that you're paying for and the maintenance costs. And then in terms of energy savings as well. So you can see down here, this later point, the AWS and Microsoft both report that you can improve your energy efficiency by anywhere between 22 and 93%, which I realize is a pretty large, broad margin, but it really depends on the specific application that you're looking at. So the other flexibility related thing is performance, because you buy a laptop and then 5 years down the line, that laptop is no longer the most cutting edge hardware, right? And so with cloud computing resources, because the remote computing center is always constantly upgrading their resources and things like that, it allows you as the user to maintain access to sort of the most cutting edge, up-to-date hardware without really investing in it constantly yourself. Another thing is subscription-based licensing, which is a pro for some people and a con for other people. A lot of companies really like having sort of a sustained cost over time. They like having access to the most recent version of the software, and they also like the flexibility and lack of permanent commitment. So it allows you to sort of try out a software for a little while outside of just the trial version. And so, yeah, a lot of people like having that flexibility. Additionally, there's reduced maintenance costs. So if you're a company, it means that you have to, basically, because you're not maintaining your own servers, you don't have to hire as many IT folks to maintain those servers for you. Um, and if you are a professor, you don't have to have one of your graduate students spend a lot of time and energy maintaining servers instead of doing research. So there's a myriad of reasons that people are interested in cloud computing, particularly quantum chemists, and um, these are things that we wanted to keep in mind as we were sort of delving into this realm of cloud computing, because a lot of our customers were asking, do you have a cloud computing product? And we wanted to make sure that we maintained these benefits as we were building our new cloud computing model. So initially, in 2022, we took an initial stab at this, right? We did our initial Q Cloud launch back in, like I said, 2022. Um, and basically, this involved the customer launching a bunch of EC2 instances, so basically nodes in Amazon's warehouse out there, wherever they've got it, using a pre-built AMI. So an AMI is an Amazon Machine Image, which basically means that it has all of the software that you need to run your calculations preloaded on it. So you don't need to install Q-Chem, you don't need to, do any extra fiddly stuff. It's basically ready to run out of the box. So this setup would be done via the AWS console. So you see this little box here? That's what the console looks like. So you would follow this step-by-step process to basically launch your own instances using this pre-built AMI. Um, and here are the instances. You can see all of them over here. A bunch of little nodes, basically, and each of these is an EC2 instance. And then you would collect the private DNS of each of these instances and send it off to the Q-Chem office. And we would add it to our license server, which is remotely hosted. And basically, that would, you know, each of the private DNS is listed as associated with each of these nodes, telling us that, the node has permission to run Q-Chem. Basically, it has a license for it. And then you would run jobs by directly SSHing from your computer or workstation into each of these nodes and running calculations. Now, you can see this is, this was nice in that it allowed people to use AWS architecture who didn't have their own on-site computing hardware, which was nice. That was a great step up. But there were a couple of pitfalls with this. And some of you may have already spotted some of them, but we'll step through them a bit. We'll call them challenges. So the first challenge is the setup is a little bit cumbersome. For us in the office, it feels a little bit less cumbersome because we've been tinkering around with AWS trying to set up Q-Cloud and things like that. So we're a little familiar with the console. But most people who haven't run on AWS before might find it a little tricky. Like, what is an EC2 instance? What is CloudFormation? What is the IAM identity management thing, right? And actually, I went back to our instructions, and it's a multi-page thing that I printed it as a PDF, and it's like 5 pages long of just instructions on how to get this set up. Which again, for us in the office, it didn't feel as cumbersome because we were already familiar with that console. But we wanted this to be as seamless a process for setting this up as possible for our users. Perhaps a little more stressful, or I guess, important, is the manual shutdown and startup of nodes. So basically, this flexible scaling was one of the things that I mentioned as like one of the most important points, right? Is that these resources scale up and down as needed, so you're not paying for hardware that you're not using. In this model, you basically, if you aren't using a node, have to SSH into that node, or no, sorry, you don't have to SSH into the node, but you have to go into the AWS console and shut that node down or stop it and start it based on whether you need it or not. And this is a problem because ideally you would want these nodes to automatically scale up and down as you need them to run your calculations, right? That's part of the whole point of cloud computing, and this model kind of misses the mark on that a little bit. So in terms of job management, which is kind of related to what we were talking about, but basically job submission could be a lot easier. So you can do via SSH, right? But you could also do through IQmol. But that process could be a little bit easier, SSHing into specific nodes. But the more pressing thing here is that there's no queuing system. Which, if you have ever managed a group of people who's more than you can count on one hand, basically, or even below that number, you'll know that that's kind of a problem. You really do, when you're working with this sort of infrastructure, kind of want a queuing system so that people can queue their jobs, especially if you're running in a high throughput sort of way. You want to be able to just queue up a bunch of jobs and let them run, and be handled by the queuing system, right? Um, the other thing also is it's not self-contained, right? Um, so there's like this external Q-Chem license server, and we wanted this to be, something that the user could kind of handle as independently as possible. Um, and also, it doesn't allow you to, I guess, if you want to change the types of nodes that you have, you would have to contact the Q-Chem office again to sort of give us the new private DNSs of it, and it adding that private DNS step was a little cumbersome and placed additional burden on the user, which we didn't want. So that's, basically these are the challenges and things that we kind of wanted to solve as we were moving to the next iteration of QCloud. So, we got this feedback. We had a couple of users who used it, but it never really caught on, probably for these reasons. And so we sat with this for about 2 years and sort of quietly developed an alternative model that we think works quite a lot better. So let me talk about that model a little bit. So these are the solutions to the challenges presented on the last slide. The setup process, as previously mentioned, was a little cumbersome. And so our solution to that was to create this automatic setup of the Amazon side infrastructure via a Python-based command line interface, which would be a lot more familiar to most of the folks who would be using this product, right? In terms of job submission, we added a Slurm-based job submission and control to the cluster. And then we also added job submission control and retrieval to the Pythonic command line interface for users to use. So yeah, as previously mentioned, we wanted to sort of add this flexible scaling in, which would also require adding a queuing system. And the queuing system is useful by itself as well. So we added this sort of cluster-like Slurm-based queuing system. And the overall structure is a lot more cluster-like. And then in terms of user management, we wanted to create a better process for that as well. So we use AWS Cognito on the back end for that. So, new Q-Cloud framework. There are 2 packages available on PyPy. There is Q-Cloud Setup, which is used for all of the administration of the cluster. So setting up the cluster, launching it, modifying the number and type of nodes available on that cluster, adding users, removing users, things like that. We also have Q-Cloud User, which is used specifically for job submissions. So if you have, for example, if you're the PI and you have a bunch of students in your lab, all of the students would mostly just be familiar with the Q-Cloud user end of things, right? And Q-Cloud setup would only really need to be used by whoever's administering the cluster in that group. So there's sort of this one-step installation that's handled via Q-Cloud install that installs all of the Q-Cloud related stuff for you. And so the initial setup works basically like this. There is one step which was unfortunately unavoidable. We tried very hard to avoid this, but we couldn't. So whoever's setting it up does need to go into the AWS console to set up the command line interface access keys. It's very sensible that they make us do this because they don't want random command line interfaces accessing your Amazon account. That's totally valid. So once you've done this though, you can go ahead and contact our team for a license key, and that license key basically sets up the license on your cluster. So because that license is self-hosted, you don't need to have any sort of additional contact with the office after that initial license key is sent to you, which is nice. Um, and then you obviously install QCloud Setup, which is handled via the QCloud install script. And then you configure the cluster and launch it, and then you add any users as needed. Um, this command line interface does also have infrastructure for, I guess, adding or yeah, sorry, for modifying the cluster. It also has infrastructure for tracking the amount of resources that you're using and sending a notification whenever the cost exceeds of the AWS resources exceeds some set limit that you have provided. Um, and there's, a couple of other nice things in there that Andrew's added for us, which is great. Um, so I don't know about y'all, but I like a good diagram. So let's sort of diagram it out a bit to talk about the way that the setup works. So you start with QCloud setup with the cluster admin, right? And as I previously mentioned, they get the activation key and the access key from the Q-Chem office and the AWS console, respectively, right? So, they get both of these keys and they run the setup script to create basically three stacks in AWS. Um, one of them is QCloud users, which is responsible for controlling user access to the cluster. So it basically launches a Cognito service, which manages users and passwords and access tokens, that sort of thing. Um, and you can add and remove users this way. There's also a QCloud API gateway, which is what is used to submit jobs to the cluster itself. And also you can use that to access results from your calculations once you've run them. QCloud cluster itself this is basically the heavy lifting. This is the cluster. So this looks a lot more cluster-like than our last model, more like a cluster and less like individual workstations. So you have a QCloud head node here, um, and then this set of nodes that are sort of created and started and stopped as needed. So these are allocated as you run jobs and then deallocated once those jobs are complete. And then all of the stuff is kind of stored in here, basically. And then as a user, once all of this has been set up by the admin, you basically can submit jobs and obtain results via the QCloud user Python package. So yep. And like I said, we've also built in some like cost estimation stuff and things like that, which is helpful, hopefully. So we had a couple of there were some iterations with this. We had some of our board members run it and we tested it in the office a little bit and to sort of iteratively improve it and make it a little more user-friendly and try to work out any bugs. So in terms of configuration considerations as you're setting up the cluster, there's a couple different things to consider. You should try to create a unique VPC for QCloud if at all possible. This is a virtual private this thing. And yeah, this is not always possible, but if you can, it would be ideal. There are also a bunch of different types of nodes that you can allocate. This is one really nice thing about cloud computing is the fact that, you can switch up the node types on your cluster. So, costs do vary, so please choose based on your needs. If you're running like, H2O with a minimal basis set, that's going to look very different than if you're running a couple cluster calculation on a large transition metal molecule, right? The needs for those are going to be different. So you can look on Amazon's website for more details on what these different types of nodes are. So then in terms of the number of compute nodes, that's kind of set based on the license that you have. So just make sure you select the correct one there. And then in terms of scratch volume, that's also going to depend on the type of molecule that you're running and the type of calculation that you're running. Just as a frame of reference, 100 gigs of scratch costs about $10 a month the last time we checked. So I'm going to talk through a couple of use cases, and then I'm going to do I'm not going to do a full demo of the setup, but I'm going to do a quick sort of demo of submitting jobs and bringing them back. Um, so a couple quick use cases, just so you can see how this would be potentially useful for folks. One use case is high throughput screening. So if you have, let's say, a medium-sized company that has a dedicated theory team, um, they want to screen several thousand organic LED candidates for efficiency based on predicted singlet triplet gaps. Um, and the problem that they have is that this screening is something that they need to run kind of infrequently, right? Um, but it requires a significant amount of compute power, but it doesn't make sense for them to, buy an entire cluster, the number of nodes that they would need to run these sorts of calculations at this volume. That would be really inefficient, and purchasing an entire cluster just to run this every, month or two wouldn't necessarily be a good allocation of their resources. The solution to this would be to basically purchase a large scale Q-Cloud license, um, and then run on AWS hardware. This basically circumvents the need to purchase all of that, to both purchase and maintain all of that themselves. Um, and that avoids unnecessary costs and energy consumption. And then the costs associated with that would be like the monthly Q-Cloud license fee and the AWS fee, which is a lot less than maintaining an entire cluster themselves. And because they can kind of turn that on and off as needed, they can, choose to only use those resources when they actually need it as a company. Second use case is sort of like a risk reduction thing. So let's say there's a small company that doesn't actually have a dedicated theory team, but a couple of researchers have a like hybrid theory experiment background, and they kind of want to start incorporating a couple of calculations into their, I guess, their experimental work to sort of help validate their experimental results and understand them a little bit better. And some high-level electronic structure methods could, help with the development. For example, if they're studying transition metal complexes for CO2 activation, they could use like EOM couple cluster methods and energy decomposition analysis to help them understand better what's happening in those reactions. But the problem is that these are high-level methods that, in order to obtain the requisite level of accuracy, need a lot of computing power. And there's no way for this team to demonstrate the benefits to the rest of their team in terms of, you know, how these calculations are helpful in understanding their experimental results. In order to do that, they would first need to invest in the fairly costly hardware, making this idea kind of a high risk venture for the company overall, right? Um, the solution to that would be to buy like a low volume Q-Cloud license where you're only running like 10 jobs or so at once, and basically rent out the AWS hardware. This significantly reduces the initial startup costs associated with this particular venture. Um, and it also provides high performance utility without any sort of like long-term commitment to it on the company's part. So if the company decides that it's not working for them, they can just choose not to continue with it, and they won't have a bunch of extra hardware or a permanent license or anything like that lying around. So, um, another use case is for an academic group. This is happening a lot in Europe right now, where a university is decommissioning central computing clusters due to rising electricity costs, right? Um, and so this group basically wants to maintain their research trajectory without any on-site hardware, especially if it's a new professor and their group is going to be scaling up. It's a little difficult. First of all, you need a physical space for hosting your own local cluster in the lab, right? And probably the requisite cooling equipment, depending on how large the cluster is and things like that. There may not be expertise within the group for maintaining a cluster, and even if there is, if you have a group of graduate students, you don't necessarily want them wasting a bunch of their time um, on something that you didn't hire them to do. You hired them to do research work. You didn't hire them to, you know, maintain your cluster for you. Um, and also the group might fluctuate in size a little bit as well, right? Um, and so the solution to this would be for uh, sort of, if you purchased a Q-Cloud license, you could basically scale that up as the group grows. So you may initially only need like, you know, 10 seats at once or 10 calculations running simultaneously at once. But as your group grows, you can scale that up as needed. And then the setup is pretty straightforward. It's straightforward enough that a grad student could probably handle it for you, the cluster administration and things like that. And then in terms of cost monitoring, which is particularly important for a PI of, you know, a small group, there are automatic cutoffs and notifications. So you can basically set it up where an email sends once a certain threshold in terms of monetary spending is reached on AWS resources. And then you can also log into the AWS console to see how many resources are being used and look at costs and things like that. So now I'm going to do a really quick demo. So, and like I said earlier, I'm not going to go through the whole process of setting it up. There will be a video for that. Andrew is working on it, and it should be uploaded around the same time that this video is uploaded, and I'll link to it for those of you who are watching on YouTube later. I'll link to it in the comment section below. But I did set up a Q-Cloud cluster earlier, and let me show you how to submit a job. Which one am I submitting? I think it's this one. There we go. So I'm just doing this Q-Cloud submit, and this is the job name. Let's see, it's gonna sit there for a second while it submits. And you can see we get the submitted job ID back, right? So we've got that. And then if we want to check on the status of the job we just submitted, we can do Q-Cloud status. And it gives us this very nice list of jobs that I have submitted. You can see I've already got, one of them that I submitted this morning that already finished running, and then the one I just submitted is still in the queue. If there were a job that failed, there would be error or failure over here. It shows the status over here. So if I wanted to obtain the results of the calculation I ran earlier this morning, what I would do is Q-Cloud get, and this guy. I could also use the job ID if I have multiple with the same name over here. There we go. And now I can change into this directory and look at the output. Yeah, you can see that here. And then, yeah, there's more on this in the documentation, but there's, arguments that you can make up here to pass along to the Slurm scheduler, which is pretty nice. So, okay, so that's just a really quick demo. That's, again, I'm not doing any of the setup or anything like that, but that's basically the job submission and retrieval. And yes. So I think we're just at about 30 minutes. So this is just about it. Thank you so much to the Q-Chem team who has worked really hard on getting this together, developing this, testing it, getting it sent out and everything like that. Specifically Andrew, who's really taken the lead on this. And then also former team members, Peter and Evgeny, who both had a pretty significant hand in developing this. And then thanks to the Q-Chem board for all of their testing and things like that. and to Sarah for figuring out a lot of the logistical stuff in terms of the product development. Also, thanks to the Q-Chem developers, because our software package would not be possible without their contributions. And also thank you to all of you for your attention. Thank you so much, and I will see if there are any questions. It looks like there are. Okay, someone's chat is still disabled, so I will fix that real quick. Hang on. Okay, perfect. The chat is now on. Thank you for letting me know about that. There we go. So it keeps exiting from this thing, so I'll go ahead and exit out of this keynote presentation. But does anyone have, if you have any questions, please post them in the chat. There we go. Do we have any comprehensive cost analysis so that one can compare the cost with the local runs? We do not have a cost comparison. What we do have, because the cost comparison is going to vary pretty significantly based on the energy consumption of your individual machines and how much you're paying for your electricity costs, because that varies from region to region as well. But in terms of cost analysis, in terms of AWS stuff, we do provide some tools in the scripts themselves for cost estimation. So we try to be as transparent as possible about the AWS costs themselves, if that kind of makes sense. So if you wanted to do a comparison yourself, we try to make that as easy as possible to do. But because we don't, yeah, any case studies, not at this current moment in time. But we will try to keep track of those in the future, because this is a new product that we're just rolling out now, basically. So yeah. So yeah, thank you. Um, and are there any other questions? How does QCloud work with existing paid licenses? So QCloud is a separate licensing model from our existing paid licensing model. It is a software as a subscription model, which is, there was discussion about how to do that, but that was a decision that we made because that's most of the times how software is deployed on this sort of architecture. But we are offering a 50% discount to people who have existing Q-Chem licenses, like permanent Q-Chem licenses, for their Q-Cloud subscription up through, I think, the end of 2025 right now. But that's consistent with our offsite license extension installation costs. So yeah. And we do have pricing information on our website, but I think it might be a little hard to find right now. So I can send that to you if you're interested. So thank you. See one in chat. Okay, perfect. Thank you. Okay. Does anyone else have any other questions? Let me grab the licensing cost for you real quick before we leave, because I do have that available. There we go. So I'll just link to this. Here we go. Oh, I accidentally clicked the wrong question. There we go. Um, but let me respond to that real quick, and let me post it in the chat as well in case anyone else is interested. Um, so uh, Christy is asking, could you provide information on the add-ons required, similar to those needed for other software like Amber? How will these be managed in Q-Cloud? Um, so basically, there aren't any additional add-ons. I mean, there are additional add-ons required, but the installation of those add-ons is handled via the Q Cloud install script. Um, so that was actually one point of feedback as we were iterating with the board a lot about this, was that the installation process, because it required a lot of external Python packages and things like that, we just wanted to streamline that installation process. So yes, this is basically, you shouldn't, I think, need any additional software requirements in order to run this. It should all be perfectly encapsulated. Um, or the only things that you should need to worry about as the user are the qcloud install script, and then the two Python scripts that are installed by that installation script and the dependencies. So and then there is a follow-up question. Thank you for this follow-up question. I very much want to address this one. Is QCloud planned to completely replace local licensing? Absolutely not. This is intended as a alternative option for people who are interested in running on AWS architecture in an easy and straightforward way using a software as a subscription model. And actually, if you want to use a permanent licensing model on AWS architecture, you're perfectly welcome to do that still. This is definitely not replacing our permanent licensing model. We anticipated that we would get a lot of backlash for that, justifiably so. And so we want people to definitely be reassured that this is not at all replacing our local licensing model. So yes, hopefully that answers your question. We want people to basically have as many options available to them as possible. And there was demand for software as a subscription model, but we don't want to supplant all of the people who do enjoy having a permanent licensing model too. So, yes. Does anyone else have any other questions? Okay. Well, if no one else has anything, as always, there is going to be a forum topic posted about this shortly after this webinar wraps up. And if anyone has additional questions that they think of after the end of this webinar that you go, oh, darn, I wish I'd asked that, you are welcome to ask that in that thread, and I'll do my best to answer. And this should be posted on YouTube within the next week or two. So thank you everyone very much for your time, and definitely reach out to us if you have any additional questions. Thank you so much. Take care, everyone. Have an awesome Tuesday. It's a Thursday. Have an awesome Thursday. Bye.